The topic of this video is constructing a model using variation. Let's look at a problem. The horsepower, HP, that a shaft can safely transmit varies jointly with its speed in revolutions per minute, otherwise known as RPM, and the cube of its diameter. If a shaft of a certain material 2 inches in diameter can transmit 36 horsepower at 75 revolutions per minute, what diameter must the shaft have in order to transmit 130 horsepower at 80 revolutions per minute? Okay, so this is very clearly a mechanical engineering problem. Let's go through the 6 steps. Notice that for this problem, we're going to predict the future. What diameter do we have to have in order to meet these certain design criteria? All right, step 1. Write the quantity or expression that varies followed by equals. Well, it says the horsepower that a shaft can safely transmit varies. So you might notice that there's no variable provided in this problem. HP is not a variable, it's a unit of measurement, like inches. So we have to come up with a variable to represent horsepower. We're going to use the variable that's used in a physics class, capital P. In fact, I'm going to make a short list over here of the quantities that we're measuring, horsepower, the units of measurement, and the variable we're going to use. So horsepower, capital P. So I'm writing P equals. Step 2, write the constant of proportionality K in the numerator of a fraction. Step 3, identify the ly word for the problem, directly, inversely, or jointly. Well, in this problem, it is jointly. So that means that we are expecting 2 or more quantities, and they all need to go in the numerator. So let's see if we can find what they are. It says jointly with speed in revolutions per minute and the cube of its diameter. Notice there are no variables for those either. So what is the variable used in a physics class for speed measured in revolutions per minute? That would be a Greek letter called omega. Even though I'm not there with you in the room, I want you to pronounce that out loud. Omega. This is not a W, this is omega. So this is spinning speed. And revolutions per minute, or RPM, is our unit of measurement. And then diameter, we're just going to use D. That's pretty easy. And in the problem, it says 2 inches in diameter. So inches are the units of measurement for this particular variable. All right, so now that we've got our variables, we can go ahead and continue with our steps. So jointly with speed, so that means omega, and the cube of its diameter, so that means d to the 3rd power. Both those things go in the numerator where they're multiplying with k. Step 4, if you have an empty denominator, put a 1 there, and then simplify. So we get P equals k omega d cubed. All right, we continue on. Step 5 is where we replace all letters in our equation except for k with numbers. If a shaft of a certain material 2 inches in diameter can transmit 36 horsepower at 75 revolutions per minute, notice that they are giving us a number for D, a number for P, and a number for omega. So let's put all of those in there. So P, the power measured in horsepower, is 36, equals K times omega, the speed measured in revolutions per minute, that's 75, times D, the diameter measured in inches, which is 2. And notice that that's cubed because the D was being cubed. That allows me to solve for K. So 36 equals 2 cubed is 8. 8 times 75 is 600, and 600 times K would be written 600K. Now, divide both sides by 600. This gives us the value of K. I'm going to use a calculator here. 36 divided by 600 equals 0.06. 0.06. Now, one of the things that I want to point out to you right now is that this says a certain material. So the K value for the material for this problem happens to be 0.06. If we changed the material, then the K value would be different. So putting this in here gives us our equation that we can use to predict the future. P is equal to K, which we know to be 0.06 for this certain material, omega d cubed. Okay, this is our equation that we can use to predict the future. If somebody gives me two of these three variable values, then I can predict what the third variable value must be. Which brings us to our last sentence. What diameter must the shaft have in order to transmit 130 horsepower at 80 revolutions per minute? All right, so 130 horsepower, that's telling me P, and 80 revolutions per minute, that's telling me omega. So let's plug those in. So P is 130 equals 0.06, omega is 80, and D will leave as the letter D because the question says what diameter. It's what we're trying to solve for. All right, so we get 130 equals, I need to know what is 80 times 0.06, 4.8. Now I want to solve for D. I need to get the D cubed alone, so I divide by 4.8 on both sides. Using my calculator, 130 divided by 4.8 is 27.083 repeating. Now take the cube root of both sides to get D by itself. And we discover that D is exactly equal to, by the way, the cube root button. On this calculator, there's a caret button, which looks like an upward pointing arrowhead. And above that, it says X radical. So for a cube root, the way you would enter that is you tell the calculator what kind of root you want first, which is a 3 root, a cube root, by hitting the 3 key. Then you green shift and hit the caret button, which turns that 3 into a cube root. And then you can put your 27.083333333333333333 enter. And D is 3.0030832 ... or D is approximately 3 inches. So, if I'm the mechanical engineer, my job is to do all of these calculations and then go find my fabricator and tell the fabricator, please make me a shaft with a diameter of 3 inches so that it meets the new design criteria.